On 3.2, I can't remember what question.
3.2 homework or worksheet? Homework? All right, let's
I got a
take
couple questions too.
on the 3.2 homework
And 3.
and 3.3 prep. Okay, so we'll get rid of the prep for now. And let's check out the 3.2 homework. All right, any idea which number?
Is it 5, 6?
What's that, 5?
Yeah, no.
And 6.
6,
11.
5, 6, 10, 11, and 12. Perfect. Okay.
5.
All right, so let's take a look at 5.
7.
So just a reminder of what BAC means. It's the amount of alcohol per amount of blood, and that's both measured in grams. So here, if they give us a BAC of 0.1, what does that really mean? What does 0.1 represent?
Thousands.
See, so BAC 0.1. So remember, that's a percent, even though we don't necessarily write that down. So we got to convert that to the decimal, yeah. And percent means divide by 100. So this is divided by 100, shifting the decimal twice, we get 0.001, which, thinking about that as a fraction, that's the tenths, hundreds, thousands, that's 1 out of 1,000. Okay. And this question asked, I think specifically, out of 1,000 grams of blood, how many grams of alcohol would this BAC represent? So just converting that, we got the answer right away. The answer for that one would be 1 gram of alcohol for every 1,000 grams of blood. For the next one, I can set up a proportion since it's not going to come out as nice. So 0.02 is the BAC on that one. So if we had a BAC of 0.02, so I'm just going to set up a proportion. A proportion is where I have two fractions that are equal to each other. The BAC means 0.02 out of 100 because it's a percentage. So that's the translation of that. On the other hand, I want to know what out of 1,000 that's equal to. And so we can just use cross multiply and divide to solve this right here. Would be another way to attack this. So 0.02 times 1,000 is going to be what? 2. In your calculator, you got 2. And the other side, I get question mark times 100. So dividing by 100, we get question mark has to be 2 out of 100. Which would be, that would be correct. It would be 20, wouldn't it? Yeah, thank you. We get 20 out of 100, which would be 2 out of 10, or 0.2. So 2 hundredths out of 100 would be the same as 2 tenths out of 1,000, is what we just figured out. So this would be grams of alcohol for that problem there. So next one says, use the information from the website. So you need to go over to Wikipedia and check this out. Have we talked about Wikipedia in this class last term? Is Wikipedia a good source of information or not? It depends on the topic. Yeah, for the most part, it is a good source of information. Does anybody know why, say, English teachers ask you not to use it as a source? No, it's not that anybody can change it because they really can't. Most popular articles have a moderator, and anyone that tries to change it, they have to go through the moderator first. So the moderator will look at your change and say yes or no, and it may or may not be seen by the public. The real reason it's often teachers restrict it is it's not a primary source of information, it's a secondary source of information. And so at the bottom of any article, or in any article, there's going to be links to other articles. And then they'll have sources for things, like where the heck did this information come from? And so often you'll see superscripts like this right here. And here's where the real information came from. So although you wouldn't be able to cite Wikipedia as a source for a research paper, you could go to that original site there, first read Wikipedia's, it's like Cliff Notes. You ever hear of Cliff Notes? It's just an abbreviated version of the real research out there. And then Wikipedia lists where they got their information that backs up this. So it is a good source of information for most things, but it's not a primary source. It's a secondary source of information. So let me zoom out a little bit and read the directions here. So here, let's see, the website to list effects on an individual having a BAC as given. So according to the website, take a look through here, they list what somebody might experience if they have a certain BAC. And so I just wanted you to look at what a given measurement leads to that person, their behavior, and any impairments they might have. And just make a note of those in each box for that. All right, skipping on down, number 10. So here we have an equation where we're given R, and R is equal to this formula right here. If we were to plug in numbers for T and calculate R and plot those, we would find it made a nice straight line. So this is a lot like the BAC we were looking at earlier. T is retired in the year T. So if T is 1995, that means they retired in 1995. And so given a particular year, this equation is supposed to tell us the percent of people that retired. But here they're doing it backwards. They're giving us the percent and they're telling us to find the year. So that means we got to solve an equation. So we'll do that in two different ways here. We did a problem like this in class yesterday, the BAC. So screenshot. Let's get the formula. And the first question asked about, was it 10%? Yeah. And it says R as a percentage as a decimal. So what should I write instead of 10% for R for that first one? 0.1. So for the first one, we're given that R is 10%, which should be 0.1. And that's going to be equal to T over 873.36 minus 2.15. And I mentioned before yesterday in the past course that solving an equation is the reverse of plugging a number in. If I knew what T was, first I would divide, and second I would subtract. To solve it, I have to do that in reverse. So first thing I want to do is get rid of the 2.15. How do I do that?
Add to.
Yeah, since it's involved in a subtraction, we would add 2.15 to both sides. You can do it in other orders. It's just this is the easiest, most efficient way to do it. All right, so then I'm going to get, if my arithmetic is right, 2.25 on the left side. This adds up to 0, so I only have the T divided by 873.36. All right, how do I cancel out division?
Multiply.
Yeah, so I have to multiply both sides by that denominator. So on this side times 873.36, and on this side times, let's run the room, 873.36. So I whip out a calculator. The whole point of doing that is the multiplication and division cancel each other out. So whatever's on the left side has to be T. Anybody with a calculator? Yeah.
1,877.
One more time, 1,000?
877.
1,877.7. That seems a little low. I have a mistake anywhere here.
I got 1,965.
That sounds more like it.
0.96.
All right, so double check your calculation. What was it again, Robert, that you got?
1965.96. 9/6.
9/6. So we probably round that up to 1966 would be the year for that one, right? And the bottom line here is, are we going to repeat the same procedure each time? If somebody gives me a percent, first thing I'm going to do is I'm going to add 2.15. After I do that, I'm going to multiply. So I'm just going to do this one more time in a slightly different way. So I've got one answer, but I'm going to make the next two answers easier to come up with. So starting with the equation, R equals T over, help me out here, was it 873.36 minus 2.15? So here, I'm not going to replace R with a number, I'm just going to leave R there. And what I want to do here is I want to solve for T. What's the first step we did before to solve for T? Yeah, add the 2.15. So that's going to give me R, I don't know what it is yet, plus 2.15. That gets rid of that on the other side, and so all that's left on the right is T over 873.36. And then what do?
Divide.
Not divide,
Multiply.
we multiply. The trick on multiplying there is, we got to put the R plus 2.15 in parentheses to indicate we got to do that first. And then we can multiply it by 873.36. Multiplying cancels out that denominator, so the only thing left on the right side is T. So this is another way to come up with the answers. If you plug in a percent here and first add, then multiply, you'll always get the right year. So give that a shot using that formula for the next number. Next number I got, and I think we probably all got the same numbers on this, is 15%. So I think this one is 1966. I'm going to whip out my Google calculator. So I want to take 873.36 times parentheses 0.15 for 15% plus 2.15. Close parentheses, and Google says that comes out to 2008, 2009. Anyone else get that? Yeah, so now we have a formula that just automatically gives the answer if we have a percent instead of a year. I'm going to type 2009 in there. Oops. It's over here somewhere, right there. And do the same thing, but plug in 0.2 for 20%. And my calculator says 2052. Anyone else get that? A couple nods. No? Yes? No? Okay, so we have this formula, right? All we want to do is plug into this formula. So on my calculator, I'm just going to type that number times parentheses whatever percent I was given. In this case, I was given 20%.
So R is the percent.
R is the percent, yeah. If we look back here, it says R is the percentage as a decimal. So here, 20% would be 0.2. So I'll retype that here. Let's see, is the Google calculator working on this computer yet? I still got to figure that out. All right, so starting over, 873.36 times parentheses 0.2 for 20% plus 2.15. Those parentheses, hit enter, and I get about 2052 on there. So we'll do that one other way just to cement that in. Let me just see if we're right. 2052, submit. Ooh, I got them right. All right, so it gave me the same numbers again, but I'm just going to redo it for 20. If the solving the equation thing wasn't working for you today, again, we can always go back. So we have our formula, R equals T over 873.36, and then we add, we don't add, we subtract 2.15. And here we're given that R is 20%. 20% means 20 over 100, which reduces down to 2/10 or 0.2. So I've got 0.2 equals T over 873.36 minus 2.15. And again, solving an equation is always the reverse operations in the opposite order. If I knew t, this would be first and this would be second. Since I don't know t, this has to be gotten rid of first. So I would add that 2.15. And that's going to give me 2.35 equals t over 873. What do we do next? Get rid of division, we multiply, right? So we go times 873.36 on each side. The whole point is multiplication and division cancel, leaving just a t, and now I just have to carry out that multiplication. And I think when we plug that into our calculator, again, we're going to get 2052. So the point of solving it here, leaving the r as r the whole time, means instead of having to go through those steps over and over again, this just says, hey, just do those steps, and that'll give you the reverse answer. We're just undoing it in one shot. It can be helpful if it's something you have to do a lot. All right, what do we got next? 11, is that right, Jenna?
Yes, sir.
Okay. All right, so we got crown molding being installed over the joint between the walls, room in the ceiling, similar to baseboard, but it's at the top, no gaps. All right. The dining room ceiling is rectangle with 4 feet 9 inches by 13 feet. Crown molding costs $24 for 8-foot pieces, and we want to purchase 10% over due to waste on the corners. So what's the perimeter of the dining room in feet? How many 8-foot boards do we need? And then what happens if we put on a 9.4% tax? Ooh. All right, let's do it. I'm going to grab that information. So new page. 14 feet 9 inches. Hang on, let me get it copied in here and we'll do it together. So I really only need this bottom part right there. Okay, what's a good first step for a problem like this? Draw a picture. Yeah, totally. So that'll help me keep track of things, and it gets that out of my mind so I can think about other stuff. All right, so we have this top-down view of the ceiling, and we've got 14 feet and 9 inches that way, and 13 feet going the other way. And sometimes I worry about drawing it to scale, other times I don't. Usually when I start off, I don't care about drawing it to scale. So the first thing I want to do is find the perimeter. And so I'll just make a note that there's 14 feet, 9 inches on this side, and there's 13 feet on that side. So we just have to add all those numbers up. So perimeter. We could use a formula for this if you remember a perimeter formula, but this is simple enough. I don't think we need to worry about formula. So what's that going to give me? 10, 20, 30, 40, 6, 50, 54. So I got 54 whole feet. And then I have 18 inches. All right, what's the problem with 18 inches?
It's not feet.
Yeah, it's not in feet, so 12 inches in a foot. So this one right here would be 1.5 feet. So I'm just going to call it 1.5 feet. Is that okay? And so if you weren't sure about that, you could just take the 18 inches and multiply it by the fraction where inches is in the bottom and feet is in the top. And I know 1 foot is 12 inches. So on my calculator, I just say, hey, what's 18 divided by 12? Because 12 is in the denominator. My calculator will tell me that it's 1.5 feet. So we've got 55.5. Am I doing okay? Anyone else get that? Yeah, okay. And again, it's a good idea to calculate this yourself too, and not necessarily trust me because I make mistakes all the time. All right, so next thing, this is sold in 8-foot pieces. So, he decides to purchase enough to allow 10% waste. due to possible loss at corners. So what should I do first? Should I figure out the number of 8-foot pieces, or should I factor in 10%? Is it going to make a difference? What's that?
You've got 55.
Yeah, so there's a couple ways to do this, yeah. So we could just right away say, hey, let's think about the 8-foot pieces, so new page. So we have 8-foot pieces, and we could take the 55.5 feet, divide that by 8 feet per piece, which will give us the number of pieces. And so how many times does it go in there?
6.9.
6.9. So, you know, we got to buy a whole piece, so we're going to have to round that up to 7 pieces.
8 times 7.
Okay, and 8 times 7 is 56, which is just over that. Okay. All right, so then it says he wants to add in 10% more. So if I want 10% more, we talked about this before, and we'll play with it some more this term. That means I want 110% of what we currently have, of the current state here. So what happens if I take 110% of 7? What do I get? Let me whip out a calculator, help me out here. Here we want 10% more.
Yeah, but why would you just take 55.5 times 0.1?
Do it there. Okay, I'm going to do it 2 different ways. Yeah, so that's another way to look at it. So some of us are looking at the problem and it says do the 8-foot pieces, then do 10%. And Robert's thinking, no, I want to do the 10% and then figure out how many pieces that is. Am I going to get a different answer? That's a different order of operations. If you change the order of operations on some numbers, will you sometimes get a different answer? Answer is yeah, you sometimes will. So let's just see. What's 110% of 7? I got 7.7.
How'd you put that in a calculator?
What's percent mean?
Like, how would you put it in a calculator?
I know, I'm getting there. What's percent mean? Divide by 100, right? So if I divide this by 100, that's going to give me 1.1. So I want 1.1 times 7. 7.7, I got a nod from Aaron. So that would be 7.7 pieces. Can't buy 0.7 pieces, so I got to round that up and say, okay, I need 8 pieces. So Robert said, hey, maybe we should do the 10% first. I just want to look at it that way. So I've got 55.5 feet, and I need 10% more. Anytime you add on 10%, a shortcut is to say you need 110%, which would be 1.1 times 55.5. Can't do that one in my head, I don't think. Somebody with a calculator help me out.
61.1.
61.1?
The 5.
Okay, and that's feet. So now we think about 8 pieces, so we want to take that 61.1 feet, divide by that there's 8 foot per piece. 8 goes into 61, 7 point something times what?
7.6.
7.6 times. Slightly different answer than we got over here. Different order of operations. It's in the ballpark though. I still need 8 pieces. So it turns out it didn't matter too much here. It can. So either method, however you choose the order of operations, is one of these better than the other? I don't think so, but I bet somebody could find an argument that says, hey, this second way of doing it is better, or somebody else might find a reason that the first way is better. So there's just 2 different ways to do it. They both lead to about the same answer. We need 8 pieces. All right, so I think we're ready to finish up this problem. This is a fun one. We haven't done one like that in a long time. All right, perimeter, I think we got 55.5. How many 8-foot boards were needed? We believe there's 8. Oh, okay, now we got to figure out the cost. So let's see, they're $24 a piece plus a 9.4% sales tax. So everybody write something down, see what you get, and then we'll compare that to what I get, and we'll see what happens. So everybody try something, write it down. Let's see, what am I missing here? Let me copy this into a new page. And make a note that we need 9%, 9.4% sales tax. All right, and we got a number. What you got?
192.
I think that's a little low.
I got 210.
210. Anyone else? Yeah.
I got 210.
210. Okay, we had a couple 210s. I got 210 and 5 cents. So, but it's 210, 5 cents. What's another 5 cents? All right, so let's double check why. So first step, I think, would be to just take 8 times 24. And let's see, what does that give us? That gives us 192. 2 ways to proceed from here. One way is to just multiply by 9.4% and then add that back on. So we could say that the amount of tax is that 192 times 9.4 is a decimal, which would be 0.094. And we get a number out of that. Get a number out of that. I get that's $18.05 if we round up. And then we add that to the 192. So the total should be 192 plus 1805. Yep, that's 210.05. So that'd be one way to do it. Another way to do it is, are we paying 9% more roughly? So as a percentage, what's the total we're paying as a percentage? Think about the last thing I did with that 10% more. When it was 10% more, what was the total percentage that we paid?
110.
It was 110%. Yeah, so if we're paying 9% more, what's the total percent that we're paying? 109%. Yeah, so another way to do this would be to take, let's see, new page, slides number 5, is to take our 192, that's without tax, and multiply that by 109%, which would be 1.09. Don't forget that little fraction of the 0.4%. So just whip out your calculators. What happens if you take 192 times 1.094? I think you'll get 210, about 210.05. I think it's 210.048. It's the same number we got before. So sometimes it's nice to think out of 100%, because that kind of whittles it down to 1 step instead of 2 steps. Not a huge deal, but sometimes that can be beneficial. So anytime I can, I'm going to remind you of that fact. We looked at it a little bit last term. It'll come up again this term. All right, we're rocking and rolling on this stuff. 12. I'm going to leave that one for another day. So you guys try that if you haven't already. If you're still stuck on it, we'll go over it tomorrow.
Is there one that's like 3 or 4?
There's something up here you thought was a pain.
That.
With fractions?
I'm thinking, was that? I figured out that one. There's another one. It was with fractions.
Let's do one with fractions for fun. Sure. All right, one more and then we got to move on. So I'm going to do, I don't know which one looks good. B, A, they're about as hard as each other. Let's do B. All right, so let me get a screenshot of that. New page, screenshot. B. So the only catch here is we got fractions to work with. And so most calculators do fractions pretty good, but often they convert them to decimals, which is sometimes a pain. Like just whip out your calculator. What happens when you type 1 divided by 6? What does it change it into?
Or 1, 6, whatever.
And that 6 goes on forever. So some fractions as decimals are a pain because they have these crazy decimals that go on forever. So here, because that is a crazy decimal, I'm just going to get rid of it and just stick with fractions. The bottom line is it's kind of the same thing we've been doing before. If I knew x, I would multiply and then what is the smallest, what is the number that both 4 and 6 go into?
12.
12 would work, 24 would work, anything they both go into. So let's say we're going to convert these to 12s. How many times does 4 go into 12?
3.
So we would have to multiply top and bottom by 3 on that sucker. So that's going to give me 3 12ths. How many times does 6 go into 12?
2.
So I have to multiply top and bottom by 2. And so that would give me 2 12ths. All right. So 2 take away 3 is what? -1. Yeah, so then I have -1 12th on that side. On the other side, I have 1/2 times x. All right, how do we get rid of multiplication? Divide. So we have to divide by 1/2 on each side. Okay, so here we have a little tricky part. How do you divide with fractions? Yeah, flip it and multiply. Yeah. So this is going to become -1 12 times 2/1. Which you could say is -2 12ths, but that reduces down to what? -1/6. Yeah, so -1/6 should be the final answer because here multiplication and division cancel out, so that should be what our x equals, -1/6. Is it right, or could we have screwed this up? We totally screwed it up, so I'm just going to check for fun. New page, check. So we have 1/2 times, we think the answer is -1/6. And then we're supposed to add on a 4th, was it? And that's supposed to equal 1/6. All right, how do we multiply fractions? Yeah, straight across. So 1 times -1 is -1. And then 2 times 6 is 12. We're adding now, so I need a common denominator. What should the denominator be? 12. 4 goes into 12 3 times. So then we're going to have -1 plus 3 over 12, which is what, 2 12ths? And 2 12ths is really 1/6, and so it does check. You got it right. Fun with fractions. Everybody loves them. Yeah, so the answer there should be -1/6. We just checked it, but this is our work leading to that. Yeah, so just try to be careful when you're working with fractions. You can double check on your calculator, but most calculators are going to spit out decimals, and you got to figure out how to deal with the decimals. Sometimes it's just as problematic. All right, next. Lesson 3.3. Let's take a look there. So first example here is to take a look at the problem we already did, playing around with that 100 and, oh, here we have a 150-pound male. Sorry, new problem. And they claim that if it's a 150-pound male that had 3 drinks, then this is the formula for their blood alcohol content over time. Okay, looking at this equation here, I'm going to zoom in a little more. Can you tell me how much this guy's blood alcohol level is going to change every hour by looking at that equation? How much? The negative 0.015, yeah. That's what we call the slope. It's a rate of change. So I just want to go over that equation, and then I'll set you guys loose on the next problem. So this equation has different variables in it, but it's a lot like the equation I talked about yesterday. In this new project, we'll talk about it also, y equals mx plus b. So m is our slope. Slope is rise over run. Rise is the change in which number? B or T here, Y or X?
Y.
It's change in Y. So for us, because I switched the Y and the B, the rise is change in the blood alcohol level. So change in the B value. And the run must be what then? Change in the X value, or in this case, change in what? Time, change in time, yeah. For this particular problem, change in time. All right, so let's take this idea right here and relate it to that number. So my change in BAC divided by change in time is equal to 0.015 by negative. Now, problem, that's not a fraction. How can I make that into a fraction? It's the easiest thing to do here. It's just divide by 1. I can just put that over 1. So is the 1, is that hours or percent blood alcohol content? The 1.
Oh, yeah, hours.
It's hours because it's in the denominator. Yeah, so this says every 1 hour, this is what the BAC changes by. So percent alcohol content. So an important thing for me is there's 2 things. One, I want you to get used to the idea that situations that have equations that look like y equals mx plus b, things line up when we graph them. And the other thing is, what does the slope mean? Okay. And to figure that out, we have to figure out, okay, what's our rise variable? What's our run variable? If it's not already a fraction, make it a fraction, divide by 1 is one easy way to do that. And so this tells us, the slope says, every hour, their alcohol content should drop by 0.015%. Okay. So that's the slope in this situation. And if we plotted some points and made a table, we would see, yeah, it drops by 0.15 each time.
Is this one need a spreadsheet?
What's that?
Is this one gonna need a spreadsheet?
It is going to need a spreadsheet, and I threw in a sample spreadsheet. So let's take a look at the first problem, and I'll show you my spreadsheet. So there's a bunch of reading that you guys need to do on your own. So there's like 2 or 3 pages of reading about slope, about what it means. So there's 3 pages of stuff related to what I went over briefly just there. Please read that stuff. It is important. I abbreviated it in 1 slide there. There's 4 pages. I lied. Okay, so here's what we're going to take a look at next. So this is on page 5. A sports team is planning a fundraiser to help pay for equipment. They plan to sell team T-shirts. They hope to raise $500. When they go to the local screen printing shop to get the T-shirts, there's a $75 setup fee, and then it's going to cost them $6 a shirt. Okay. So if they had 100 shirts made, that's going to be 6 times 100, which is $600, plus 75 is going to cost them $675 to get 100 t-shirts made. However, they're selling for 15 bucks. So what we want to figure out is how much they make, and that's the idea of profit. So let me just make a couple notes on that. Whenever you have a situation like this where you buy and sell stuff, you have cost. Oops. Got the pen. And in this situation, we have a fixed cost and we have a variable cost. And then you sell stuff, so you end up with revenue. That means you take money in. Now, technically, you don't get to keep all the money you took in because you have to pay your expenses, your costs. So then we got another idea called profit, which is your revenue, the money you took in, minus your cost. And so that's ultimately what we care about here is the revenue minus the cost. So what's my revenue here? How would I calculate revenue here in this problem?
Backwards. You're gonna make 1,500 bucks on 100 shirts.
Yeah, so it's just 15 times the number of shirts, right? So I'm gonna write that down first. So what letter should we use for number of shirts? You gotta throw in a variable here. S for shirts, good job, yeah. So my revenue right here, that's gonna be just 15 times the number of shirts, and we'll call that S.
Well, that's weird, the 5 and the S, that make.
5 looks a lot like S.
Only time you don't want that.
I'll go for it anyway. If you're sloppy, use an X. I'm kind of sloppy sometimes. All right, so then we have to minus the cost. How do we calculate the cost in this situation? 75.
6 times 1,000 shirts.
Plus 6 times the number of shirts, so that's our 6 times S. And keep in mind the parentheses I put here is important because both the 75 has to be subtracted from whatever we have for revenue and the 6S has to be subtracted. So let's just clean that up a little bit. So that really means I have 15S minus 75 minus 6S. Now we played around with cleaning up equations a while ago. Can this equation be tidied up a little bit? But here I have to subtract all of my costs. So I have to subtract the fact that it costs $6 per shirt. I have to distribute that subtraction. Right? Because all the costs, I lose that. I don't make that money. I have to pay it out of my pocket. So it ends up being a subtraction. So this is my revenue, and this, I'm taking away my costs. Can I clean that up at all? Okay, how will this clean up? Yeah, so I have 15 shirts minus 6 shirts gives me what? 9, yeah. So for profit, I'm gonna make $9 a shirt, but because of the setup fees, I'm 75 off of whatever that was. That's an S right here. That's a 5. Sorry,
Oh, okay.
Colt said that would screw things up.
I was trying to combine all of them.
Yeah, so let's go back and we'll call this an X. That's an X, that's an X, and that's an X,
Okay.
and that's an X. Okay. You're right, I should have listened to you. Wise man. All right, so this is my formula for profit. Okay, and so we can just kind of guess and check because, all right, if we sell 100 shirts, that's $900, minus 75 is what, 825 bucks? That more than exceeds the $500 goal. And so we can sell under 100 shirts and be okay. Right. So I made a spreadsheet based on this, and I want you to try and build one later. And I'm giving you the first spreadsheet. There's a second situation down here about having a $50 gift card and then buying lattes at $2.63 a day. So you're going to try that one later. So here's my sample spreadsheet. What's that? That's that cheap, I know, yeah, 263. Yeah, that problem was written a while ago. Or it's a cheap coffee shop. So I put a whole, so this spreadsheet is there for you to grab if you want. It's on our lesson 1.3 page. And I want you to try and build one from scratch. It doesn't have to look exactly like mine. So in the top, I just made a note. My fixed cost is 75 bucks. My variable cost is $6 per shirt. Revenue is 15 bucks per shirt. Variable profit is $9 a shirt. And then I started making a table. What if I sell no shirts, 1 shirt, 2 shirts, 3 shirts? And I just used that formula we came up with, 9x minus 75. Right? So take 9 times the number of shirts, subtract 75. Same thing down here. Take 9 times the number of shirts minus 75. Do I have to keep retyping that formula? No, what's the trick here? Yeah, just drag it down, right? So I could delete all these cells here. Oops, wrong button. Anyway, make believe I deleted them. And then I just take my formula and I just fill it down and it'll automatically calculate. So that's one way to build the formula. Nice thing about that formula, if somebody comes over here and says, hey, I want to make that 10 100, it'll automatically recalculate the profit to go with it. Now my table doesn't line up, but it's kind of a cool feature of the spreadsheet. I did it a slightly different way over here. Here what I did is I just typed 75 in the first cell. And then for every shirt I sell, how much money do I profit? Yeah, so every time I have a shirt, I just add another 9. And aren't I just going 1 shirt at a time here? Yeah, so I don't even reference that column. I just say, take the number above and add 9. What do I do down here? Take the number above and add 9. So I could just go 1 line at a time. And sometimes it's beneficial to make a spreadsheet that does that. Everything fits in 1 column. Sometimes it's beneficial to have a formula like that, but you need 2 columns to make that work. So what's better, having 2 columns to make it work or 1 column? Answer, it depends. Sometimes one is better than the other. So I just listed this as the alternative. I kind of like the 2 column way better because I can do more things with it. But the 1 column way, notice I'm getting the exact same answers all the time. And somewhere in here, do I get up to 500? Ooh, I didn't go far enough. But I could keep dragging these down. Now the 50 and the 49, if I just try to drag 50 down, it'll always be 50. Oops. So the trick to drag those down is get a sample of 2 to fill down. So I could do that with the formulas too. And I could just keep filling this down until I hit 500-ish. Oh, there we go. So somewhere between 63, but I have to tell 64 to get over 500. Okay. All right, so that's just there to play around with. So I'd like you for homework, if you haven't finished up the prep for 3.3, get it done. Work on this worksheet tonight, and we're going to go over some of it tomorrow. We'll meet in the lab tomorrow because I want everyone to build a couple of spreadsheets, one like this and one for the lattes on the next problem. We are out of time for fun with math, I'm sorry to say. Today is Wednesday, right? Tomorrow is Thursday. 3rd week of class. Things are kind of moving along.